Milliequivalent calculations look intimidating at first, but once you understand the pattern, they become very predictable. In this video, we are going to solve two pharmacy calculation problems involving milliequivalents, and I will show you the exact steps that make these problems completely manageable. And we are starting right now. Hello, this is Dr. Danquah, and if this is your first time here and you like to learn pharmaceutical calculations, tips, tricks, and strategies, then start by subscribing and clicking the bell so you don't miss anything. And so this question says, how many grams of potassium citrate monohydrate powder are needed to prepare 1 liter of an oral solution containing 2 milliequivalents of potassium per milliliter? And then it gives you the molecular weight of the potassium citrate monohydrate as 324, and then says round to the nearest whole number, do not include units. And so here it's important to recall that you can solve this question very nicely using the milliequivalence equation, and the version you will want to use is milliequivalent, which is MEQ, is equal to the weight of the substance in milligrams divided by its molecular weight times the valence. And so here you're already having the molecular weight, and so we can work on the valence. Now the compound is K3C6H5O7, and then you have is hydrated, so you have one molecule of water in there, and just to be more precise, when you put this in water, it's going to dissociate into the potassium cation, and notice that there are 3 of them, and then the anion is C6H5O7, and then it has a charge of -3 because the charges must balance out for the compound to be electrically neutral. And so the valence would be the absolute charge on either the cation, which would be 3 times +1, which is going to be +3 or 3, or is going to be the absolute of the charge on the anion, which would be absolute of -3, which is 3. And so regardless of which one you choose, the valence is going to be equal to 3. So we have the valence, we have the molecular weights, and then what we need is, first of all, to find the total milliequivalents in this preparation. And the way you're going to do that is to take the 2 milliequivalents per milliliter, and we're going to multiply this by the volume that we have. We are making 1 liter, and we want to convert the liters to milliliters. So a liter is 1,000 milliliters. So the liters cancel out, and then you end up with 2,000 milliequivalents. So we can substitute all these values into the equation, and we are going to have 2,000 equals the quantity in milligrams over 324 times the valence, which is 3. And so your milligrams is going to be equal to 2,000 times 324 divided by 3. Now that's going to be equal to 216,000. And notice that this is milligrams and we need to be in grams. That's what the question is asking for. So we do a quick conversion. 1,000 milligrams is 1 gram. And so that goes away, that goes away. And then your answer is going to be 216. Now this question says, what is the amount of calcium chloride in grams that will be used to make 180 milliliters of solution containing 1.25 milliequivalents of calcium ion in a teaspoonful? Round to the nearest tenth. Answer must be numeric, no units or commas, including a leading 0 when answer is less than 1. So we want to go ahead and once again use the milliequivalence equation, and that is MEQ equals the weight of the substance in milligrams divided by the molecular weight times the valence. And here again, the molecular weight is given in the question, so we don't need to do much there, but we do need to find the valence. So what we have is calcium chloride, and it has 2 molecules of water. Now, when you put this in water, the water goes in water, so there's no real contribution there. But the calcium chloride dissociates into the calcium cation, and that has a charge of +2. Then you have the 2 chloride anions, which balance it out. So your valence is going to be either the absolute charge on the cation, which would be 2, or it's going to be the absolute of the charge on the anion. So you do 2 times -1, and you find the absolute of -2, which is 2. So either way, your valence for the compound is 2. Now we also need to find the total milliequivalents that is present. And the way you do that is to take the 1.25 milliequivalents per teaspoonful. So 1.25 MEQ divided by 1 teaspoonful, and 1 teaspoonful is 5 milliliters. So that's a conversion, quick conversion. And our volume is 180 milliliters. And so the total milliequivalent is going to be 45. So you have 45 milliequivalents. So we're going to substitute all the values into the equation. So you're going to have 45 equals the amount of substance in milligrams divided by the molecular weight, which is 147, times the valence, which is 2. And we're going to rearrange the equation. So milligrams equals 45 times 147 divided by 2. And that's going to be equal to 3,307.5. But notice that this is in milligrams and we need to be in grams. So we do a quick conversion, and 1,000 milligrams is 1 gram. So the milligrams cancel out and you end up with the answer, which will be 3.3. So I hope you found this video tutorial useful. If you did, be sure to like it and share it. And if you have any questions, just leave them in the comments and I'll get to them as soon as I see them. If you'd like to learn more pharmaceutical calculations, tips, tricks, and strategies, then start by subscribing and clicking the bell so you don't miss anything. Thank you so much for watching, and I'll see you in the next video.